Children, please be ready for the pledge. Keep your right hand on your heart and please repeat. I, Shruti Narayan, commit to be vigilant and bear in mind at all times the risk to myself and my colleagues from COVID-19. I promise to take all necessary precautions that prevent the spread of this deadly virus. I promise to follow and encourage others to follow the key COVID appropriate behaviors, to always wear a mask or face cover, especially when in public places, to maintain a minimum distance of 6 feet from others, to wash my hands frequently and thoroughly with soap and water. Together, we will win this fight against COVID 19. Morning, children, we start with a new lesson, insolation. So, the atmosphere is hardly calm for a long period of time. It is in a state of constant change. The energy needed for the movement and change in the atmosphere is provided by the sun. The flow of energy from sun to earth and then out into the space is a very complex system. It involves not only energy transmission by form of radiation but also energy storage and transport. Both storage and transport of heat occur in the gaseous, liquid, and solid matter of the atmosphere, hydrosphere, and lithosphere. And this is what we are going to study in today's class. The solar energy is intercepted by the earth, and the level of heat energy tends to be more. At the same time, the earth radiates energy into outer space and the level of energy is low. The incoming and outgoing radiation processes are simultaneous in action. Hydrogen and helium are the predominant gases which are present in the sun. The core of the sun acts like a gigantic nuclear reactor and converts huge quantities of hydrogen into helium. In this process of nuclear fusion, the sun releases tremendous energy in all directions. The sun radiates energy, both heat and light, in all directions. But because of its small size, the earth intercepts only a small part of the sun's radiant energy. Therefore, children, solar radiation is the only primary source of heat and light for the earth. Now let us see the types of radiation on page 99. The sun's radiation is made up of three parts, that is, the white light which we are able to see, the infrared radiation and the ultraviolet radiation. So these are the various types of radiations which are given out by the sun. The sun also emits atomic particles called solar wind. Most of the particles of the solar wind are charged electrons, which affect the Earth's magnetic field. The energy needed for all movement and change on the earth is provided by the sun. In fact, children, where all the processes, for example, the process of photosynthesis, the water cycle, everything is powered by the sun. And you must have studied in your lower classes that without sun, life would not have been possible. Now, children, the word insolation, it means the incoming solar energy intercepted by the earth. So, the sun's energy travels to the earth as electromagnetic radiation, which can be thought of as energy moving in waves. There are short waves and long waves. The incoming solar radiation is received in the form of short waves. Heat in the form of short waves is not easily absorbed as the long waves. The sun's heat energy is absorbed by the earth and its atmosphere during the day. At night, this heat, which is absorbed by the earth and its atmosphere, is radiated out by the earth and its atmosphere. The sun's energy absorbed by the earth's surface and radiated out into outer space is called terrestrial radiation. Terrestrial radiation is in the form of long waves, and these long waves are more readily absorbed by the molecules of gases in the atmosphere. Now, children, in this slide, you can see the incoming solar radiation, which is in the form of short waves. It reaches the Earth's surface, and a considerable amount of insolation is reflected back into the space by clouds, the snow fields, and the oceans. And a very small portion, about 14% of the incoming insolation, is actually absorbed by the atmosphere. Thus, we can say that the atmosphere is actually heated more by long wave radiation than by short wave radiation. So children, just a repetition of what I told you. The sun is the primary source of heat and light, and the solar radiation which reaches the surface of the earth, the incoming solar radiation, is referred to as the insolation. And when the insolation is reaching the earth, a lot of it is actually reflected back by the clouds, by the snow fields, by the oceans, and a small part actually reaches the surface of the earth. So then the earth's surface gets heated. After that, it starts to reflect back the heat, and that heat is in the form of long waves called the terrestrial radiation, which is actually majorly responsible for heating the atmosphere. So children, now I'll be explaining you the diagram figure 13.1, which is the diagram showing the heat budget. So let us understand two important terms, the heat balance and the heat budget. There is a state of equilibrium. Equilibrium means a state of balance on Earth between incoming insolation from the sun and outgoing terrestrial radiation from the Earth, which is known as heat balance. When both incoming radiation and outgoing radiation are balanced, it is called the heat budget. So I'll be explaining you this diagram of heat budget. Now you can see this diagram is divided into two parts. The left hand side shows the incoming solar radiation and the right hand side shows the outgoing radiation or the outgoing terrestrial radiation. Then you can see the diagram has been divided further into three segments horizontally. The lowermost part, which is colored brown, is the Earth's surface. Above that, the yellow part is the atmosphere, and above the atmosphere, beyond it, is the outer space. So of the 100% incoming solar radiation, 35% is reflected back. So right now children, I am explaining the incoming solar radiation on the left hand side. So 35% is reflected back, then 14% is actually absorbed in the atmosphere. So when we add 35 plus 14, 35 plus 14 is equal to 49. So 100 minus 49 is 51. Therefore, only 51% reaches the Earth's surface. So this is about incoming solar radiation. After this, what is done is, if you see the right hand side, that is the outgoing radiation. So of the 51% which reaches the surface of the earth, 17% is reflected back from the earth's surface. And 34% is absorbed by the atmosphere. So we can say that the atmosphere is heated more by the long wave or terrestrial radiation, because 34% heats up the atmosphere and only 14% of the incoming solar radiation actually heats up the atmosphere. Therefore, the atmosphere is not heated much by the incoming solar radiation as it is heated by the long wave radiation. So children, if we add 34 plus 17, 34 plus 17 is equal to 51%. Alright, so whatever heat reached the surface of the earth is ultimately reflected back. Now here in this diagram you will see another part. 14% over here refers to the 14% incoming solar radiation plus 34%, that is the terrestrial radiation, which is equal to 48%. Now this 48% is also reflected back by the atmosphere. So whatever this balance, whatever heat was gained has been reflected back. Again, the process continues the next day. So this is the heat balance. Now children, it's very important for you to understand how the energy transfer or the heat transfer takes place from the surface of the earth. So there are three processes: conduction, radiation and convection. Conduction is the transfer of heat from one substance to another by direct contact. Convection is the transfer of heat through circulatory motion, which is caused by molecular motion. Then the radiation energy, that is radiated or transmitted in the form of rays or waves. So we'll be studying about these. So let us study how the heat balance is achieved. The balance of the heat budget, that is, when both incoming and outgoing radiation are balanced, is important for life to survive on Earth. Since the Earth rotates on its axis, and also because the Earth is spherical in shape, the sun's rays do not warm all the parts of the Earth equally. As a result of this, there are several processes which come into play and have an impact on the Earth's heat distribution. The heat radiated by the Earth's surface warms the layers of the air above it by direct contact. This is called conduction. The circulation of air and water in oceans causes transfer of heat from one medium to another or from one level to another. This transfer of heat by circulatory movement is called convection. Radiation, the incoming solar radiation, which is in the form of short waves, is called insolation. And then the earth reflects back the heat in the form of long wave radiation, which is called the terrestrial radiation. Now children, just a brief recap of what I had explained. The incoming solar radiation or insolation is in the form of short waves. It heats up the surface of the earth. Then the transfer of heat energy takes place by three ways. One is conduction, in which through contact there is a transfer of heat. Then convection currents, which are circulatory movements, as you can see, and the terrestrial radiation, which is in the form of long wave radiation. Convection currents in the atmosphere cause the land breeze and the sea breeze, as you can see in the diagram. So the L over here stands for low pressure, H stands for high pressure. During the daytime, the land gets heated intensely and the air above the land starts to rise. Now you can see the warm air rises and it starts to descend. So to take its place, the cool air from the water starts to blow towards the land in the form of sea breeze. In picture B on the right hand side, during night, the land loses heat faster. So it becomes colder, it has high pressure. It becomes, the air above it becomes cooler, and the air over the land starts to move towards the sea. The sea, on the other hand, took the entire day to get warmed up, so it has low pressure, L. The air above the sea starts to rise up. So here you can see the circulatory movement. So that is why children in the coastal areas they have equable climate in which the daytime temperature does not become very high owing to the cooling effect of the sea breeze. And that is why we do not find extremes of temperature in the coastal areas. Extremes of temperature we see in Lucknow, in which the summers are extremely hot, winters are extremely cold, which is not the case in the coastal areas, which experience equable or maritime type of climate because of the moderating influence of the land and the sea breeze. So children, we've seen in this part of the chapter that we studied that the atmosphere is heated more by terrestrial radiation given out by the earth than by the incoming insolation. Meaning, the atmosphere absorbs only 14% of the incoming solar radiation, but it absorbs 34% of the terrestrial radiation. The atmosphere also gives out the heat that it absorbed. Thus, a balance is maintained between the amount of heat that enters the Earth's atmosphere and that which leaves it. The atmosphere acts like a blanket. At night, the atmosphere, with its greenhouse gases and all, keeps the Earth's surface warm by preventing all the terrestrial radiation from escaping. During the day, the atmosphere prevents the Earth from becoming too hot by not allowing all the insulation to reach the Earth. Thus, the atmosphere prevents extremes of temperature. Without the atmosphere, the Earth would have become very hot during the day and very cold at night.